Hi folks. Today we're looking at the definite integral. At the start of our study of calculus, we said that it was essentially about two geometric questions. How steep is a function at a given point, and how much area is under a function over a given interval. So we're finally going to deal with that. For curves that lie above the x-axis, the definite integral, that means integral with boundaries, gives the exact area under the curve on some interval from a to b. So if I wanted the integral from 2 to 7 on this function below, I could just count up the blocks. And one way to think about the dx is that it's area between the x-axis in this function. So how many blockies do we have here? Well, let's see. I've got 3 full ones, and I've got 3 half ones. So that makes 4.5. And then right here I have 1, 2, 3, 4, 5, 6. Okay, so that's plus 6. The integral from 2 to 7 on that function is 10.5. Now, for an integral, unless it says find the area, we just leave it like this, 10.5, no units. We're not going to say units squared. It does come from an area interpretation, but again, we'll just leave it as the number. So in the next one, we could do the same thing, though counting blocks is kind of rough in this one. Let's think. Area of a circle is pi r squared. So in this case, we would have 1/4 of a circle, and that circle has a radius of 2. And then we have this amount here. Now, a bunch of ways that you can think of this. You could imagine that as half of a 3x2 rectangle, but you'll probably see it as a triangle. Remember, the area of a triangle is half base times height, or base times height over 2 if you prefer. So 3 times 2, okay, because this is 2 tall and 3 wide. So exactly what do we get? Well, let's see. That'll be 1/4 pi times 4, or just pi. And that will be 6 divided by 2, so that's 3. So we can leave it just exact as 3 plus pi, or pi plus 3, or we can give it approximately as 6.14. In this question, we're asked to write an integral expression for the shaded area and then calculate it. So as an integral expression, it would be the integral from 0 to 6 of the function we're talking about. You could say that this is f of x. Let's write that it's 0.5x dx. Now, how do we find that area? Well, I guess it's not too bad to just go ahead and say it's half base times height, or half 6 times 3, which should give us 9. We're also going to learn how to do this on the GDC, though. So I'll use an emulator, and I'm going to type in the function and hit graph. There it is. It's got different window settings. I probably don't really want to see those negatives, but it doesn't really matter. And I'm going to press second trace, the same place that we get intersect and we get tangent slope. And if you go downwards, you can see one of these options is an integral. And you hit enter. And now we have to tell it the left bound. And it'll be slightly different on your calculator, but not very much. So we're going from 0, that's the left bound. I'd hit 0, enter. And the right bound, I hit 6, and then enter. And you can see it's giving me that answer of 9 there. It's annoying the way that it's written in here. It says f of x dx equals 9. For you, it may look a touch different, but it's giving us that same answer. I want to show you another way to do this on your calculator. I'm going to press second mode to quit. And here I can just press math and go down. Nderiv is for the derivative at a point, or sometimes you can hack it for the function. Fn int is a definite integral. So you press enter, and it gives you this lovely setup. So we can set it up just like we see it. 0 to 6, 0.5, x. Mine defaults to dx. Yours may not. You may have to put that x in. And you just hit enter, and it gives us an answer of 9. And it does it by calculating sort of very, very small rectangles and adding up their areas. But we end up with 9 as a result. Of course, we already knew 9 was the answer. We did it geometrically. But you could imagine fancier shapes being difficult to do geometrically. The GDC will still be able to do it, and hopefully, analytically, we'll be able to do it as well. There's some practice right here on page 445 to 46, numbers 1 to 6. I hope this has been helpful. Good luck with the material, folks, and take care.